Hello, and welcome to our webinar today, Discovering Value in a Digital Twin. I'm your moderator today. My name is Scott Ward, and I'd like to introduce you to my colleagues. Linda Peters, GBD Manager, Kate Hess and Amanda Hiron, Solutions Engineers. Next, I'd like to cover some administrative details. You can ask questions through the questions module at any time. We will answer those questions at the end. There will also be 2 poll questions to give you the opportunity to interactively respond and see the collective results. The recording for this webinar will be posted early next week if you'd like to review it in the future. With that said, let's get started, and I'll hand this off to Linda.
Hey, thanks so much, Scott. And we're going to go cameras off while we're presenting to save on bandwidth. So I hope that's okay, and we'll come back with cameras on at the end. But really glad to be here today with all of you. We've got a lot to cover today. We're going to talk about a digital twin and start, of course, with what is a digital twin, and then we'll put it in perspective of ArcGIS. We're then going to take a look at the digital twin recently created for the country of Grenada. We worked with both the Central Statistics Office and the Ministry of Land there, and so we've got a great story to share with you around that. So I'll start with an overview, and then I'm going to invite my colleagues, Amanda and Kate, to show you some examples. And then again, we'll open it up for questions at the end. So please, as we're going along, if you have questions, please put them into the questions window. We'll be excited to see what is of interest to you. So let's get started. First, a definition of what is a digital twin. Digital twins really are a virtual representation of the real world, including physical objects, processes, relationships, and behaviors. And GIS allows us to create a digital twin of both the natural and the built environment. And of course, here at Esri, as we think about digital twins, we start thinking about how the ArcGIS system can be used to create that digital twin. Because ArcGIS, as you all know, is open and it's services based, it's distributed, and it's extensible. And it provides us with the tools we need to create a digital twin, from feature extraction from imagery or lidar, to running deep learning models, to spatial analysis tools. It gives us the flexibility to support the building of this digital twin foundation in this open, extendable framework, supporting your work. Now, the world is changing a lot, and digital twins are really allowing us to begin to abstract and model everything. We're seeing a lot of different building models come out, building information models, network models, landscape models, and we want to be able to bring all of these together. And the reason that we want to do this is that digital twins help us. They help us with managing the high cost of updates, give us increased efficiency, improve our accountability and transparency towards achieving our goals and the sustainable development goals, right? It helps us to demonstrate how we are becoming more sustainable. And it allows us to give access to data to many more people, both within our government, but also out to citizens. So it really helps us maximize our investment and simplify our communications. Now, I want to give you just a little bit of background about the work with Grenada. As I mentioned, this is a project we did in collaboration with the Grenada Central Statistics Office, as well as the Ministry of Agriculture and Lands. They were our project sponsors. And if you're not familiar with Grenada, it is a landmass in the Caribbean. It's made up of several islands, including Grenada, Carriacou, and Petite Martinique, as well as some smaller islands. The total area is 348.5 kilometers squared. It's not a big area. It's about the size of the greater Baltimore metropolitan region. If you're from the U.S., that'll give you an idea of the size. They've got a good sized population there. Their capital is in St. George's. And this is what it looks like there. It's a beautiful place. It's a volcanic origin, has a mountainous interior, just a really tremendous, beautiful spot, a lot of tourism, but they also lie at the edge, the southern edge of the hurricane belt. So disasters are a critical thing for them to keep an eye on, flooding, landslides, things like that. The goals behind this project for Grenada were really about things such as economic development and sustainability, as well as disasters, as I mentioned, disaster planning, disaster preparedness, and disaster response. But we also are looking at how we could use this data in the census planning process, as well as physical planning across the island. Now, the data that we use is what you see here. We started out with some topographic lidar as well as aerial imagery. This was flown by our partner Fugro, and they had some really nice, high quality, high resolution data that they provided to Grenada. They also had a classified point cloud, some interpolated layers, both a DSM and a DTM, as well as all of the ortho photos, and even some bathymetry data. So a really rich data set to begin to build off of. So what we want to do now is start with a little video tour. So I hope that you are buckled in, and let me turn on this quick tour for us to get us started.
Let's fly into Grenada and interact with both the original sensor data and the derived GIS content that makes up the 3D digital twin of the island. The initial elements are aerial imagery and the elevation surface, plus the dense lidar point cloud content being shown on top of it. This data all came from the recently acquired aerial survey for the island, and it serves as a foundation for Grenada's 3D base map. LiDAR points look realistic when showing the captured RGB colors, but they become more powerful when they are classified into the type of objects that they've hit, be that vegetation, building, or power line. With classified LiDAR, GIS features can be extracted from the point cloud. Individual buildings can be identified and assigned an address and an owner, as well as an estimated location and size of trees, and then these can be used to plan for a more resilient future. For example, we can model a 4-meter storm surge and see what it might do to infrastructure. A virtual world can be used to model and analyze real-world problems before they happen. Analysis can be run on the derived elevation surface from the point clouds to detect potential hazards such as landslide areas. As we fly along and see where landslides are more likely to occur, the 3D base map helps us understand the potential risk to people and property. And such analysis can be scaled out for the entirety of the island. The same is true for flooding potential from rivers and waterways. Knowing where they are, how they could spread out in a flooding situation, and what buildings and power lines could be impacted helps with better planning and risk management. Tourism too can be served by highlighting hidden gems like Grand Etang Lake. A digital twin model connected with the expertise of people who understand what potential disasters and planning challenges the island faces allows the nation of Grenada to plan for its future in the best way possible.
So hopefully that gave you a sense of the country itself. With that, now what we'd like to do is take a look at some demonstrations, but I might ask my colleague Scott first if we could run a first poll question.
Certainly, Linda. Our first question is about what interests you about a digital twin. Please choose all that apply. We have creating new foundation for my city, county, or country, application area disasters or public safety, application area of economic development or sustainability, or planning. All very good uses of digital twin.
All critically important, but be interesting for us to understand what resonates with you. Again, the answers to these help us determine areas for additional webinars.
All righty, gonna close it out now and let's share the results. Let's see what we got here. Looks like planning.
Yeah, that's great. Great.
Yeah.
I'd love to see sustainability up there pretty high too. So thanks so much for that.
Yeah. All right. Now I'd like to hand that over to Kate.
Great, thanks, Scott. So the 3D scene that you just saw in the video there was combining many different output products that we've generated from the raw imagery and the lidar data. I'm going to go through how we made some of those products, and I'll start with the 2D story to look at what we created from imagery and how that came together to form the digital twin. To start with, as Linda mentioned, we received the high-resolution imagery for the whole country of Grenada. And looking here, you can clearly see the building rooftops and other features like roads, which we're going to extract using deep learning. We also received elevation data, like this hillshade, which we created from the digital elevation model. And we can use this to identify drainage patterns and model flooding and landslide risk. The goal of our project was to take this raw data and derive from it layers and datasets that will be useful foundational GIS for the Grenada government to use for urban planning, emergency management, natural disaster preparedness, and as a base for their census. Hosting and analyzing large volumes of imagery data was vital to the creation of the digital twin. We used ArcGIS Online's hosted imagery capabilities and performed all of our advanced raster analytics in the cloud. Let's zoom back in to look at the high-resolution imagery and see how we can do the raster analysis on this imagery online. We're going to use deep learning to extract the building footprints, saving us from weeks of manual feature digitization. We can do this using the Detect Objects Using Deep Learning tool. And all we'll need to do is input our imagery and then select a deep learning model to use to detect objects. We're going to use one of the pre-trained deep learning models available through the Living Atlas. So for this imagery, we used the building footprint extraction model that was trained on USA data. We have another version that was trained on building footprints in Africa that we could also use depending on our area of interest. And today we'll use this building footprint extraction model without adding any additional training data, but that is also an option. Running the tool out of the box, we'll get this output. And you can see that we've successfully identified building footprints for the entire island. This process took about a day to run, saving us a lot of time of manually digitizing these building footprints. With our other deep learning models, but using that same tool in ArcGIS Online, we were able to extract roads, as you can see here in the dotted line. And when I zoom out, we can see the land cover classification that we also performed using a deep learning model in ArcGIS Online. Next, we used the ArcHydro tools in ArcGIS Pro on our DTM data, so the elevation data that I was showing at the beginning. And from here, we were able to extract highly accurate streams, as well as flow networks, which are key inputs for flood modeling. From here, with these layers, we can start to do more complex analysis. For example, identifying areas susceptible to landslides. Within ArcGIS Online, we can perform raster analysis. So if I open up the raster function editor, I can see in the Living Atlas or in ArcGIS Online that there are hundreds of different raster function chains available to you. So you can use these as they are or customize them to your analysis. I created a landslide susceptibility model. And you can see here we've chained together a series of raster functions, including calculating the slope from our DEM and taking into account our rivers with a distance function and that land use that I did using the deep learning model for the classification. When I run this model, I get a landslide susceptibility layer for the entire country. With a similar process using another model, we were able to calculate flood susceptibility. You can see in red the areas that have been flagged as being highly susceptible to flooding. We can update all of these outputs in a year or in a few years whenever there's new imagery available, using the same methods with the pre-trained deep learning models and the raster function chains, And that way we'll be able to see how the island is changing over time. We can continue to work with all of this data in our 2D maps, running additional analysis, creating buffers, doing travel time analysis, etc. But this becomes even more powerful with the added context of 3D. Even without lidar, we can bring the layers that we've created from imagery into a 3D scene. So I can take a look at that landslide susceptibility layer overlaid on an elevation data and see how it lines up. And then we can add those building footprints that we extracted. To bring them even into 3D without any lidar data, we can perform a 3D extrusion. So we can set the number of meters that the buildings are going to be extruded to above the ground. So I can change it to 10 if I want to make them a little bit taller. We can build this out further, making the buildings look realistic by pulling colors from the underlying imagery. But already, just from our imagery data, we were able to create a digital twin that we can start using for urban planning, public safety, emergency management, and more. With the addition of lidar data, our digital twin can be made even more accurate. I'll pass it to Amanda now to show how we extracted additional features and insights about Grenada from lidar data.
Awesome, thanks, Kate. Here, I'm in ArcGIS Pro, and using what was provided to us by the Country of Grenada, we started with lidar points that were already classified as buildings. And even though there are tools in ArcGIS Pro that can help us classify all of the buildings from the lidar, the vendor had already done this part very well. So, to first generate 2D building footprints, we decided to use the 3D base map solution to process the lidar points, and then use those footprints to generate the 3D building features. Looking at the 3D base map solution, there's a set of easy-to-use tasks that are specifically designed to help guide you through the process of creating different 3D representations from lidar. In this example, we needed representations of buildings and trees. So we ran the process called Create Buildings in order to automatically create 55,000 building footprints using those lidar points that were classified as buildings. From there, the building footprints were then regularized so that the sides of each building would either be straight, angled, or circular. Once that was complete, we then used the elevations that were generated from the lidar to automatically create 3D buildings from 2D building footprints. The 3D building roofs were then colored from the imagery, and side colors were applied at random based on photos of Grenada's capital. As for the trees, those were also created using one of the 3D base map tasks to extract tree points using surface analysis of the lidar, and then further selected using a normalized difference vegetation index that indicated the differences between trees and other tall features. With this, a total of 4.5 million trees were collected across the islands of Grenada. These can be compared with lidar collections in the future in order to determine any tree growth, tree reduction, or tree height differences in areas that have trees. Additionally, a topographic map was then created of the entire country of Grenada. And by using a tree canopy that was created by creating a tree canopy that was generated with height from the lidar classified as trees, as well as the normalized difference vegetation index based on the imagery, the basis of the topographic map was formed. Topographic contours were derived from the lidar and smoothed to be cartographic. Rivers were created using hydrology tools from the digital terrain model, and the building footprints were added from the lidar extraction. Spot elevations were then generated using raster functions from the digital terrain model and scaled so that less points and less contour intervals would be shown as you zoomed out. This data will be added to the World Topographic Map, as well as other existing base maps that are part of Esri's Living Atlas, making it easily accessible to the country of Grenada. Here, I'm showing you the different scales going from 1 to 2,000 up to 1 to 20,000 to show how the spot elevations, the contours, and how the features would all look in the World Topographic Map once they're added. So now that you've seen how the various components of the digital twin were created, let's look at some potential applications of this data for real-world scenarios. First, 3D twins are a powerful tool for natural disaster resilience. For example, we can use the digital twin as a base for flood and storm surge modeling to help us see exactly which buildings and which infrastructure would be impacted in different scenarios. To help us do this, we have the ability to compare what 1 meter of sea level rise would look like, which is what I have it set at right now, to even viewing what 3 meters of sea level rise would look like. From here, I can see exactly which buildings and which roads might be impacted by 3 meters of flooding while zoomed in and panning around the area. Here's a closer look at how this area would be impacted by a scenario like this. We can also run a model to identify which areas are low-lying and considered susceptible to the impact of flooding with a combination of data, including the vector stream dataset, multispectral imagery, rainfall data, as well as terrain derivatives. This is our flash flood susceptibility map, and on it, the high-risk areas are highlighted in red. We could use information like this to take action, such as using it to generate an evacuation plan in order to help guide citizens to shelters for safety. This is just one example of how a digital twin can really enable us to better prepare for potential natural disasters like flooding and storm surges. But there are other natural disasters that a digital twin can help us prepare for as well. For example, GIS can also help Grenada prepare for and respond effectively to landslides. We can use raster data sets like soil type and 3D measurements such as slope and aspect to anticipate which areas may be at greater risk of a landslide occurring. This is the output for the entire island, and all of the areas that are more susceptible to landslides are highlighted in orange. These calculations can inform efforts to fortify and protect susceptible areas of the island against landslides, such as an area where there are buildings on a hillside in a high-risk area. We can use extracted data like roads, buildings, and landslide susceptibility to help improve planning and response on the ground for first responders. These two disaster preparedness scenarios for floods and landslides are just some of the advantages of a digital twin and how they're a powerful tool for natural disaster resilience. Outside of natural disasters, another sector that can benefit from GIS is the management of critical infrastructure. So for this one, I'm going to jump to Carriacou and look at the power lines that were extracted from the lidar. Here, I can pan around the entire scene and begin to explore the area more closely, looking for places where there seems to be some vegetation encroachment on the power lines. And from the looks of it, right here along the coast, there's one area in particular where it looks like there are a number of trees that are actually getting pretty close to the power lines. The closer I get and the more I pan around the different angles, I can confirm that it does look like there are a few tree branches that are nearly touching some of these power lines. And because of that, this is probably an area that we would want to go ahead and send a maintenance team to in order to help clean it up a bit. This is an example of how digital twins allow us to be more responsive. And so far, we have talked about how the digital twin can enable us to anticipate and to react. But this technology also enables Grenada to plan and to grow. And what I mean by that is that we can use data sets such as land cover classification, along with the extracted buildings and roads, to help us identify areas for potential new development. For example, if I were to zoom in over here, we can clearly see that there's an area that's been identified as having low vegetation, while also being in close proximity to roads and other buildings too. Essentially, we have the ability to visualize whether or not it would be easy to work new construction into this already existing infrastructure. Turning off the land cover, I can see more clearly that this is, in fact, an area that we wouldn't need to cut down as many trees in order to put a new building or new housing development. In this way, digital twins can enable sustainable and efficient urban planning, while also minimizing negative impact on the environment. From natural disaster resilience against floods and landslides, to the management of critical infrastructure, to enabling sustainable and efficient urban planning, there are many benefits of a digital twin, enabling us to do more with less. And with that, I'll pass it back over to Kate.
Thanks, Amanda. Now I'm going to go back to our 2D buildings and show how we can use this data in census. The building footprints that we extracted from Imagery will be used for pre-enumeration planning. So we can divide the buildings up into balanced enumeration areas, assigning, for example, 50 buildings to each enumerator or to each area for the enumerators to then go out and collect information on the condition of the buildings and on how many people live there. So when I run these tools that we have available in ArcGIS Pro, we can divide the buildings up, and you'll see them here colored based on the enumeration area they've been assigned to. With the buildings divided up, we know exactly how many enumerators we need to hire and where to send them. And because we have the spatial location of the buildings, I can pre-fill geographic information to the building polygons, like adding the parish or county code and adding building numbers. This saves time for our workers when they go out to collect data in the field. And additionally, we can use these building footprints to drive the assignments feature of Survey 123. So I'll just connect my device so that you can see what this looks like for someone out in the field. But essentially, having the building polygons when you go out into the field on the device allows you to assign each enumerator a specific set of building polygons, so they know which buildings they're supposed to be collecting and they know exactly how long it's going to take. So it makes for easier planning for the timing of the census, as we can see exactly how many buildings each person's going to have to visit. We can make sure that they're all optimized, that they're close together, and ensure that the whole census process is going to be really more efficient and more accurate because of having the building polygons planned out. So I can just open this up in the Windows version, but this is going to look the same as how the building polygons will show up on the device. So when I open up the survey, I can see this inbox number, so I have 99 buildings that I've been assigned to collect data on. And when I first open this up, I can see the list of all the buildings and can select to start collecting from here, or I can go into the map view. So in the map view, I can see that border of my enumeration area, and I can see the high resolution imagery as a guide. And then when I zoom in, I can see that extracted building polygon that we got from Imagery and select one of these buildings to start collecting more data. So when I open it up, you can see that I already have, as I mentioned, that parish number, the enumeration district number, and the building number filled in for me. And I can go and collect additional information, like the village or community that I'm collecting information within, a description of the building, and then more about if this is a residential building. If it's residential, I can get additional information about the dwelling. If it's occupied, I can collect information about the household. So filling out the name of the head of household, the number of people who live there, and a contact number. And those are the questions I'm prompted if this is a residential. If it's a business, I'm prompted with a different set of questions about the business. Or if it's an institution, you can see there's a different set of questions here. So once I've surveyed the building and submitted my data, it's going to associate all of that information that I just collected back with the building point. So now I know that I've already visited this building, I can move on to the next, and my supervisor can go ahead and look at that data that I've just submitted. So back in the office, my supervisor can be looking at this dashboard where they can track how many surveys have been completed in each enumeration area, see our progress overall through the data collection process, and then they can also see on the map buildings that have been visited already are symbolized with a white outline, and buildings that need to be revisited for more information have a dashed outline. So having the imagery-derived building footprints allows us to make the census more accurate and efficient. streamlining the whole process, from planning the enumeration areas, to collecting data in the field, to monitoring the progress through the enumeration in near real time. And we can continue building on this digital twin with additional analysis and foundational data. With the building data that we've now validated in the field, we can create an addressing system for the country, enabling improved delivery of services and speeding the time of emergency responses. Having a digital twin for your country or your state or city increases efficiency. It enables more accountability and transparency and allows you to collaborate across the government and with other agencies, thereby maximizing your investments in data, people, and technology. And with that, I'll go ahead and pass it back to Scott for another poll question.
Thank you, Kate. Our next poll question is, what area would you be most interested in learning more about? Please choose all that apply. We have feature extraction, deep learning, 3D modeling, raster analysis, and spatial analysis. Give you a few moments to, I should say, about 30, 45 seconds to answer this question, and then we'll share the results.
Yeah, this is a really interesting question. I've always been more partial to spatial analysis myself, but raster analysis has really become so powerful. So interesting to see what's important to you.
All right, gonna close this and share our results. Pretty close in feature extraction and 3D modeling.
That's great.
And back to you, Linda.
Thank you. Thanks so much. Let me turn my screen share back on here. So we've covered a lot. Let's see if we can summarize a bit for you here. And let's start with a review of some of the steps needed to create a digital twin, because you have to start with the data, right? It's always about the data, obtaining the data, and then processing of the data. But it's also about dissemination and most importantly, probably building the stakeholder engagement, getting the use of this data, again, across your government within different agencies. So if we look at this, you can take advantage of ArcGIS Pro and the 3D base map solution to help you streamline, to go into those workflows of classifying your lidar data and extracting your 3D base map for your digital twin. You can start also with an existing point cloud, as we saw here today. You can automatically detect and classify those features, and you can extract and support hybrid visualizations of your data. So this is a very powerful solution. You can simply extract and showcase 3D models as well. So why is this so important? Again, I know I talk about this a lot in the webinars, but the challenges we have today are many, right? The demands on us for a broader range of information, more real-time data, better resolution data, right? We're all dealing with these pressures, as well as the issue of privacy. And how do we do that with smaller budgets and oftentimes fewer people? So with a digital twin, we can help enable a lot of these things. We can leverage technology and expand our ability to increase the amount of data analysis and information that we can deliver. We can enable analysis with these new deep learning algorithms and tools. And we can do faster analysis, which means we can run and rerun some of these models with different parameters to get better results. And again, we can speed the time of information to our decision makers. So with that, I want to thank you for your time. We want to leave some time here for questions, but I want to leave you with some resources because there are some great resources out there. There is a new digital twins page at Esri, as you see there in the top bullet. We're also trying to put a lot of different resources together. So some articles, some blogs, some videos, There's some great story maps and some learn lessons coming on as well. And for those of you who are interested in the models, that last link is a link to all the deep learning models available through the Living Atlas. And there's quite a few of those now available, including different building footprint models, one here in the US, one in Africa, and we'll continue to add more and more models over time. So with that, Scott, I'm going to throw it back to you to kick us off into a Q&A session.
Certainly. Thank you, Linda. Right, looking at our questions we have here. One was, that's a great video. Is that online anywhere? Linda, do you know if we have that anywhere online?
That's a great question, and not yet, but great idea. Yeah, we'll do that.
Also, it will be part of this video for the webinar when it gets posted. That said, I have a feeling what was asked for was just that video, which we'll look into. Do you have a method for verifying models, such as when a landslide actually occurs? Is there a plan to review if the model detected this? Kate?
Yeah, so it's not built into that specific model, but we could certainly design a different one that's going to take into account either historic landslides, so using as an input training, so we could add additional training to that model based on where historic landslides have happened, and then update that as additional landslides happen. So that's definitely possible within the technology, but not in that particular model.
Excellent. Thank you, Kate. Next question is there a tool for extracting desert trees that are typically less than 30 feet tall? Kate?
So for extracting them, I assume you mean from lidar. It is going to be a little bit more difficult for shorter trees. We have lidar classification tools that, especially if so when the lidar is collected, we can classify each of those different pixels or returns to be ground or forest or buildings, etc. So it may pick them up as trees. I would say we could also do from imagery, certainly, since that's not going to need a specific height of the trees. You could train a model to identify trees that way. But if it's from lidar, I'm not entirely sure if our tools would pick up shorter trees.
Yeah, we do have some models for palm trees as well, date palm trees. So we'll check into that and get you more information on that.
All righty. Thank you, Kate and Linda. Next question. Can we use the point cloud created with drone to map for feature extraction, such as trees?
Yeah, definitely. So that'll be, especially because it's a drone, so it's flying at a flying lower and getting more information. You can definitely use that for feature extraction. You could get trees, buildings, everything that we showed here, assuming that it's a high enough number of returns, so the high enough resolution.
Excellent, excellent. Are there plans to tie in what you've shown today with the new game engine SDKs?
Ooh, great question. I wish my colleague was here. I'll come back to you on that, but I know the gaming team is very keen to use and data such as this. So we'll revert to you on that. And that's a good point, actually. For the questions we can't answer here, up in the Esri community pages, we'll put those answers that we weren't able to get specifically for you here today.
Excellent. Are there any time-based simulations for ArcGIS using digital twins?
So time-based simulation, meaning like looking at how it would look at different times of day, I'm guessing. If
I'm
that's
guessing, yeah. The original question is, does Esri have simulations for digital twins for ArcGIS? Time-based simulations for ArcGIS. Maybe it's, again, kind of that game engine SDK kind of
Well, we
approach.
can do some sun shade projections if that's what the question is. Again, I think that's a little bit difficult to answer. So if the person who asked that could maybe give us a little bit more clarification, I think maybe we can do a better job of answering.
Okay.
Yeah, and I can show here in the meantime. So we have built into the 3D scene viewer that we can see the shadows of different buildings, and then we can change the time of day So you can see those shadows move, and clearly it's taking into account the elevation. So this shadow is further than that shadow. And you can see all the different times of day where the shadows will fall, and you can change the date. So this is in March, what 4:45 p.m. would look like in this part of the world. But you can try any different day of the year, anytime, and it'll adapt to that specific part of the world.
Alrighty. Next we have, what about 2D photos to create? We're using 2D photos to create the 3D models with photogrammetry. Does Esri support this process? Kate?
I believe so. This is another one I'd have to look into a little bit more and get back to you.
Okay, all right. Next one is, it always shows showcasing airborne lidar. What about mobile mapping lidar? Is that supported, Kate?
So mobile lidar, we're starting to look into more. These where you're doing footprint extraction and those kinds of things, airborne will be better. But we're coming out with new models all the time. So terrestrial lidar is definitely something that we're looking into as we're developing future models.
Yeah, absolutely. And again, you know, if there are specifics for what you are looking for in that, and I'm looking at the person who asked the question, please let us know. We'd be happy to you know, collaborate with you and do some testing around that.
All right. Next question we have is, what are the basics for how lidar data is acquired? Kate?
So there's two kind of main methods, as the last question kind of was saying. There's airborne lidar, so that's going to be anything that's collected. Like this that we've been showing today was collected from a small plane flown over the island. So it's just sending down essentially lasers from the plane, and then they're bouncing back up, and the receiver is seeing how long it took for that laser to bounce back to the plane, and then it can tell the exact height of what it bounced off of. So it's really precise method of data collection, and so that's airborne lidar. There's also terrestrial lidar, so you could set up a small lidar device on a tripod, and it could spin around and do the same process, but just collect the information all around the device on the ground. So those are the two main methods for collecting lidar data. There's also satellite lidar, which is pretty new and is going to be too low resolution for any of the things we're talking about.
Okay. Next question. Thank you, Kate. I have, what tool is used for extracting buildings from lidar? Kate?
Or
So
Amanda.
that's kind of, you know, you want to take that one, Amanda? You're on mute.
I said you can take it.
Okay, so we have the 3D base map solution, which you can download through our ArcGIS Solutions deployment, and that's going to give you all of the tools that you need to extract building footprints. So as Amanda was showing, it's got built-in tasks, so it'll tell you exactly what information to put in, what format your files need to be in, and it'll walk you through the whole process of getting the buildings, getting the rooftops, getting the roof heights and the floor heights, all of that data from your lidar to create highly accurate building footprints.
Alrighty, thank you, Kate. Do you have a way to report the level of accuracy when building models? Kate?
So it would definitely depend on the model, but overall, yes, we can, when you're training models, get the output data. If you're training them in ArcGIS Pro or doing something in a notebook, you'll have an output file that has further information about the specific accuracy of your model. And there's good documentation on this on the website. But if you're making so especially if you're running a deep learning model, the output accuracy is going to be in the files when you download it to your computer, and you can get more information there.
Okay, thank you, Kate. Next we have, which is better, which may make it a difficult question to answer, drones equipped with LiDAR scanner or extracting from drones with digital cameras? Do we have a preference for that with our tools?
So it just depends what you're trying to do and what the quality of the data itself is. So if you have, like we showed today, stuff you can create from imagery and products you can create from lidar, and they're both useful. If you can get both, that's the best case scenario.
Yeah,
But you can really do a lot with either.
but if you've got a really heavily canopied area, right, you're going to do better with lidar than you are with imagery.
Okay. Next question, are the building footprints here compatible with City Engine?
I believe so, but I would have to check.
Yeah, great question. They should be, right?
Should be.
It's all in
Yeah.
a geodatabase.
Yeah, it's a feature service that you can use across the platform.
Thank you, Kate. And then what is the resolution of the LiDAR data used today?
I believe was that in your slide, Linda?
Yeah, I want to say 20 centimeter, but give me a moment and I'll pull that up here. Looking. 15 centimeter horizontal accuracy.
Excellent.
5 centimeter vertical accuracy.
And that is it for our questions. Oh, wait, no, one more snuck in. What would the workflow for overlaying 2D parcel fabric data onto the 3D base maps look like? Would we need 3D surfaces derived from LiDAR to do this?
No, you should be able to use 2D parcel fabric data, and that's actually something that you can use. There's an optional step in the 3D base map solution where if you have parcel data, you can use that to further refine your building footprints. So if you have, for example, I don't know, these ones are pretty good, but if you had one building where two, in the imagery, they were pretty close together, so it categorized it as one building, but then in the parcel fabric, you could see that that was two separate properties. It would use that 2D parcel input to split that building into the two different components.
Excellent. Well, thank you, Kate. Linda, I'd like to turn back over to you.
Yeah, no, thank you. Thank you so much, Scott, and thanks everybody for all the really great questions. We appreciate you guys giving us some more of your time here again today. Again, we're going to put all of these resources, the recording, everything up into the Esri community. So we'll give you a notice of when all of that is out there, and point taken, we'll get that 2-minute video posted out to YouTube for you as well. We'll get to that right away for you. So thanks again.
Thanks, everyone.
Thank you.
Great day.